Now in this next step, I'm going to show how we can apply a function of our own design to map. We still haven't gotten to sorted yet, and we will, but I want to drive home the importance of this understanding. If we're interested in applying a function to every single item in a sequence, which is what we're going to end up doing with sorted as well, we can also determine exactly what we'd like the function to do. Previously, we used len or stir.upper or int or stir in order to modify each item. But what if we write our own function? Now, what does doublet do? Just think about doublet as its own little machine that does something. What does it do? It takes an argument, it doubles the argument, and then it returns it. That's what doublet does. That's doublet's purpose in life. That's what doublet does. Now, if we were interested in doubling every item in a sequence, we could, if we wanted to, use map. Map will apply whatever function we'd like, and if we write our own function, it makes no distinction. It just takes the function and it applies it to every item. Can you imagine what we're going to get back in S items when we're done? You might want to pause the video and give it a thought. Remember what you're reading here. Functions like map apply another function to each item in a sequence. So actually, I might ask you two questions. Here are the two questions that I would ask. Question number one. What will be in S items? Question number two. How many times did doublet get called? I think those are the two good questions. Go ahead and pause the video, see if you can figure it out, and then we'll take a look. Okay, let's take a quick look. 2, 4, 6, 8, 10. Okay, so what map did was it took each item in items, it doubled it, and then it made that returned value, the value that came back from doublet, put that into the resulting list. So the answer to the first question, of course, is 2, 4, 6, 8, 10. We're going to see the same number of items, and we're going to see each item doubled because we had the function do it. Of course, you understand that if I was to change it to 10, for example, we'll get 10, 20, 30, 40, 50. That's because I had my function return the value times 10. So it works exactly as you might expect, as long as you understand that doublet is getting applied to every item in the list. Second question was, how many times did doublet get called? Well, ask yourself, if each item is getting doubled and the function only takes one item at a time, it must have been called 5 times, and that is the case. Doublet has been called 5 times. I could even test that. I could print called right here, and might have to get a little more space here, but called, 2, 4, 6, 8, 10. So doublet was called 5 times. Now sometimes students look at this and say, well, I don't see how doublet's getting called 5 times. And that's true. You can't see it here. That's what makes it one of the most challenging things to teach and learn. Part of this is a little bit of magic, a little bit of invisibility. It's not visibly happening, but it is happening. It's happening behind the scenes. We can't see it, but we can see its effects. Doublet is getting called 5 times. Now, if you can't see that it's getting called 5 times, then where is it getting called 5 times? The answer is it's getting called 5 times in map. Map, which we can't see the code for, but it's there somewhere in our system. Map is taking doublet and calling it over and over and over again, once for each item in the list. The fact that we can use a custom function for this purpose is pretty key here. And this is the next thing that we wanted to talk about. When you use your own function, you can control exactly what happens. And of course, I was going to show you this. It doesn't really matter what the argument is, as long as the function doesn't encounter an error when it works it over. We could easily pass it strings, and it's still going to do the work that it does, which is double whatever. And of course, as you know, string times 2 means a doubled string. But the point is that we can have it do anything. We could, for example, take the result and maybe concatenate some other value to it. Let's get cheery. The result now had high concatenated to it. Now, I just arbitrarily came up with that idea, but because I wanted to, I wanted to show that I can decide exactly what's going to happen, I can write a function for that purpose. Whatever I decide the function is going to do, that's what's going to happen to that item. And so these higher order functions that we can define ourselves get applied to each item. Now we're going to move on to sorted, and we're going to see that that will be the case for sorted as well.